IATA In-Flight Broadcast Procedure, or IFBP, Part 2. So just a quick recap on what this is. Certain FIRs, flight information regions, in Africa have unreliable communications. You struggle to get hold of areas sometimes on the VHF frequencies, and therefore we as pilots and we as aircraft operators must be able to talk to each other on a specific frequency and in a specific way. And that is what we call the in-flight broadcast procedure. There's a standard procedure that everyone must follow when they fly within these FIRs. There are some additional operating procedures that you as a pilot need to follow, which is something out of the norm that you normally do, and that's what I quickly want to cover in this video. So the very first thing is, whenever you're doing a flight level change, you must use all of the aircraft lights. So you literally put on all of the aircraft lights when you're climbing or descending. That's obviously for visibility purposes, right? So that other aircraft can see you easily. Then the second thing is, when there's an imminent collision, you realize that, there's another aircraft in the opposite direction, maybe on your same flight level, or you guys have very little vertical separation. Then you must either climb or descend by plus minus 500 foot, plus, remember this, turn on all the aircraft lights, plus announce the maneuver. Tell them that you're climbing 500 foot, and also you must notify the air traffic services. This is sometimes difficult to do because the reason why we're doing this in-flight broadcast procedure is because we can't get hold of the area controller. You must try and notify air traffic services that you've climbed or descended so that they have the latest information. And then once that is done, then you can return to your assigned level when you are clear of the collision. Okay, so that's something that you need to remember, especially for the exam. Then obviously you need a transponder, so you must use mode A or C and squawk 2000 unless otherwise assigned. Okay, so that's typically for your transponder purposes. Then also when you're operating in those areas, you must have TCAS, and the TCAS system must be ACAS2. That stands for Airborne Collision and Avoidance System, and it's like, one level up from one. So there's a very specific set of systems that you need to have on board to be able to operate here. And essentially what this is, it helps you to pick up other traffic within your vicinity, showing on your navigation display, so you can see how high they are, which direction they're traveling in, what is the altitude difference relative to your aircraft. Are they below or above? Are they climbing or descending? And that must be operating your ACAS system or TCAS system. Oh, TCAS, sorry, stands for Traffic Collision and Avoidance System. That must be operating in the TA mode or the RA mode. Okay, at maximum range. TA or RA mode is basically, the TA mode is just going to warn you of another aircraft relative to your position from a specific distance and within a specific vertical separation. So this just gives the pilots a warning. The RA system is a resolution advisory. This thing is actually telling you what to do when the TCAS system picks up that there's an aircraft very close to you. So typically it will tell you climb, 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 or descend, descend, descend. Okay, so this is a little bit stronger than the normal TA one, and you need to operate that at maximum range, which is obvious. Why? Because you want to pick up all the aircraft within your vicinity at maximum range so that you know exactly who's where. That's another thing that you need to do. And then also, when applicable, you can use SLOPs, which stands for Strategic Lateral Offset Procedures. So if you're flying on an airway and you know that there's an aircraft coming towards you on the same airway or just in the opposite direction, right? Or there's one in front of you that you're catching up with, then what you want to do is you want to offset laterally, meaning you turn right, you stay on altitude, but you offset 2 nautical miles to the right, or 2 nautical miles to the left, or 5, whatever the case might be, whatever the decision is of the pilot in command. But essentially what you use is you use strategic lateral offsets to make sure that there's no collision.